which is good. All right, good. Properties of limits. So remarkably simple ideas here, like almost ridiculously simple. We look at these properties of limits, and it seems really silly to do it, but then later on when we get dealing with doing some proofs of derivatives, we use these properties, and then believe it or not, we just totally forget about them. So limit properties. So the limit of the sum or difference of two functions as x approaches a is the sum or difference of the limits of the two functions. So easy to say, limit of the sum is the sum of the limits. Limit of the product is the product of the limits. Limit of a quotient is the quotient of the limits. Limit of a constant is a constant as x approaches a. Limit of a constant times a function is a constant times the limit of the function as x approaches a. The limit of power is the power of the limit of the function as x approaches a. And the last one, the limit of x as x approaches a is a. Okay, good, as long as the function exists. All right, easy to say, not hard to memorize, I don't think. Like I say, we end up using this a little bit later, and then we don't worry about it after that. So let's make up a big, gnarly function that does as much of that as we possibly can. And we'll do this. So I want to find the limit as x approaches a. So I'm going to put a constant out here. I'm going to put a power there. I'm going to put a constant at the end that's not involved in taking a product. So I'm going to put a 2 here, and then I'm going to turn it into a quotient, and I'm going to put an x on the bottom. There we go. We want to find the limit of this function. Notice the function involves like an x, the power of x, a constant times a function, and then a constant at the end. Okay. Gee, I don't know how to take the limit. It's a good thing that I learned these limit rules a little bit earlier. So the limit of a quotient is the quotient of the limits. Okay, so 3x cubed plus 2. And by the way, do not feel obliged to like take this stepwise the way I'm the way we're doing right now. Okay, so the limit of a quotient is the quotient of the limits. Okay. Let's see, and notice that this function can't be 0, but we're going to say that a is not equal to 0 just so that we don't step on any hidden mines. Okay, I'm going to leave the bottom. I can take the limit of the sum at the top, so this becomes the limit as x approaches a of 3 x cubed plus the limit of as x approaches a of 2 all over the limit as x approaches a of x. All right, we're gradually peeling the onion. Gradually peeling the onion on this. Okay, this is the product of two things. So the limit of the product is the product of the limits. So this is the limit as x approaches a of 3 times the limit as x approaches a of x cubed plus the limit as x approaches a of 2, and this is all being divided by, oh, look at that. It's Lucas. He's dropped in on us. He has honored us with his presence. Hey, Lucas. Sorry, I know I didn't give you any advanced warning about this. Oh, I can't hear you, and I don't know why. It might actually be because my sound is not on. Oh, look at everybody's here. Hey, gang. You want to come and say hi to the PSDS gang? We can only see like foreheads and up people's noses and stuff like that, but they're all there.
Hi, PSDS gang.
Hey, gang.
We can't hear you, unfortunately. Lucas is either he's yelling at us or he's still waking up. I can't tell. We have a, oh, that is an upside down high. There we go.
Is
We-
this like being streamed
we have
to YouTube
received-
right now?
Absolutely. It's
So,
being
like,
streamed to YouTube.
This is going onto his website for the next class to watch.
Oh, I might. Oh, there we go. It's not even on this speaker. We can hear it in the next room. Don't worry, you guys are being broadcast into the next room. So the other far room here. I really do want to hear what you're saying. So I'm going to disconnect my Bluetooth devices. My apologies for this. Okay, there. Hey, I can hear you guys. I can hear you, Lucas. Yes, no, that's okay. I understand. You're going there? Wow. Yeah. That's perfectly, yeah. That's all good. Good. Thank you. But we can tune in. Yeah, I fixed it up. I shut off the Bluetooth. We could hear them. All right. And I can edit out all that chaos. I can edit out that chaos, although not too handily on YouTube. It's pretty terrible. But I think I can do it. It's just a matter of cutting it all out. Okay, good. We should have chosen value for A. That's for sissies. No, I know. It's easier to think of it as a number, but you're right. It is actually just a number. Yeah, so it could be, pick a value, not 0. 6. Okay, so A is going to be 6 when we get this whole thing done. All right, okay, so we're way down here. There's only one thing I'm really not sure about. It's this limit of a power. So we'll burrow our way into that, and then I think we'll be all ready. We'll be all ready to come up with an answer. So this is the limit of 3. A limit as x goes to a of 3, and this is the limit of as x goes to a of x cubed. I think I'm getting this right. Plus the limit of 2 as x goes to a. Have I missed anything? I don't think I have. It's a lot like logs because there's an awful lot of there's an awful lot of the word. There's an awful lot of the limbs in here. Okay. Oh, really? Well, you better. You better. Okay. So the limit of a constant is just a constant. So that's 3. The limit of x as x goes to a is a. The power of the limit is that. And this is the limit of a constant as x goes to a is the constant. And the limit as x goes to a of x is a. There we go. Do not feel obliged to like do that. Just if I actually asked you to do this, which I might not, do it in one step. Don't like do all that. That's just crazy. No, I'm saying you go from this step over here down to this step here, right? Or this step, if I'm really fussy about it. And but A is 6. We decided that because somewhere deep down, it's not satisfying unless A is actually a number. And so let's put 6 in here. Notice we didn't put in 0. That says but A is 6. Yeah, it does. The most egregious use of the word but ever. Okay, plus 2. And this is not a 9. This is an A, which is actually a 6, which if you were dyslexic might have looked like a 9. 36 times 6 is 180 plus 36, so it's 216. 3 times 216 is some big number. But I could do that and that, right? So I can get rid of that 3. Oh, no, I can't do. Oh, my goodness, I can't believe I just did that on YouTube. Oh, can't do that. Okay. Anyway, somebody puts this into their calculator.
And they get 108.
Like for the whole thing. And it's 108, just the way we thought it would be. Anyway, that's the properties of limits. That's easy. It's the end of calculus for today. That is so easy. End.